Okay, so today we're going to be looking at circumferential velocity. With circumferential velocity is related to, where is this boy that normally sits there? Maybe he's still coming, or maybe he's online. Now, with circumferential velocity, there is a general formula for determining circumferential velocity, which is pi dn. And then the concept is coming from the fact that if you look at this diagram here, if we have a point P making one revolution in 1 second, and that the distance covered will be equals to pi d or 2 pi r. So pi d is the circumference of a circle. Of course, the 360, that distance there represent the circumference of a circle, which is 2 pi r or pi d. So this formula is coming from that concept of the circumference is 2 pi r. It can also be written as what? Pi d. And then the n now represents how many times that point has exhibit a circular motion. So the formula for calculating circumferential velocity is pi d multiplied by n. And then you must take note that your n has to be in what? In revolutions per second. I think I explained something yesterday that I think with this question here, the revolutions per minute and the revolutions per second. So it's still the same thing. So with the circumferential velocity, there's nothing much. And then it brings us to a summary of some formulas. I explained some of this yesterday here. The relationship between linear and angular quantities like the velocity, the acceleration, and the distance. So this is the comprehensive formula. You can write it down. You can see from here, uh, from the formula for angular velocity, which is 2 pi n, this is going to be W2 is the final angular velocity minus the initial divided by time. So this is actually coming from the fact that the angular acceleration is the angular rate of change of angular velocity or change in angular velocity per unit time. And then when we are talking about change, we have to subtract the final from the what? From the initial divided by time. Of course, with the time t, it has to be in what? It has to be in seconds. And then these are the formulas connecting the linear and the angular quantity. This is for velocity, this is for acceleration, and this is for distance. This is for angular displacement, which is in theta. So you can see from this, there is a little formula here. It's gotten from the fact that velocity is distance over time. And then your distance is velocity multiplied by time. So in terms of the angular, if you want to use the angular quantity, the distance, we are going to be talking about the angular displacement. And then with the velocity, we have the angular velocity multiplied by time. So most of all these formulas are gotten from the linear formula. So it's just a matter of changing them to the symbol. Which one is linear? How do we write the symbol for the angular quantity? The same thing applies to this one, the one for angular acceleration. Acceleration is the rate of change of angular velocity. So when we talk about rate of change of something, it has to do with time. So with the linear, is going to be the final velocity minus the initial velocity divided by time. Okay, so with the final velocity being the final angular velocity and the initial velocity being the initial angular velocity, then divided by time. So most of the formulas are generated from the linear quantity concept. So it's still the same thing. The only thing that I just want us to take into consideration here, the formula that connects the linear and the angular quantities together is those three: for velocity, for acceleration, and for distance. Okay, from there, we are going to be looking at some activities here. I think this one is 8 marks. It's 2 marks each. The first question here says that we have a flywheel that rotates. So the first thing that I want to see here is your data. Before your test, I will let you know which chapter to focus on. Okay, I will tell you what you must focus on and what not to focus on. So the flywheel rotates at 18 revolutions per second. So I said with revolutions per second, I'm going to represent by that by small letter n. So this is 18 rev per what? A sec. Now that flywheel has a diameter of 0.4 meters. Sometimes you'll be given in centimeters or millimeters. Make sure that you convert to meters. So which make the radius to be what? 0.2 meters. So the question says that we must calculate the first thing here is the angular velocity. So with the angular velocity is 2 pi n. So which is the formula? This is the formula that we are going to use. So we just do our straight substitution here. So which is 2 pi multiplied by what? 18. So 18 times 2, this is going to give me 36. 36 pi, and 36 pi will give me what? 36 pi will give me what? 36 pi will give me 113.0. I'll just write it as 113.09 radians per seconds. So with the second question there, the circumferential velocity, we are still going to be using the same formula, which is pi dn. So with the circumferential velocity, is going to be pi. The diameter is what? 18 there. So with the circumferential velocity, is going to give me 0.4 multiplied by 18. So with the circumferential velocity, it's going to give me 22.619, which is 22.62 meters per second. So remember, this is circumferential, but it has to be meters per second. The angular displacement there, the angular displacement is theta. Remember that the angular velocity is a rate of change of angular displacement. So that your angular displacement is going to be equals to your angular velocity multiplied by time. So the angular displacement, the angular velocity is the one that we calculated in A here, which is 113.09 multiplied by the time given to us is 3. So you multiply that by 3. Linda, I'm going to be tasking you, you're the one that will be punching calculator for me, be giving me the answers. So you're going to be writing and be punching calculator as well. I want to be engaging you. So give me the value for the angular displacement there. Hmm? 339. Are you sure? 339, comma what? Comma 27. What's the unit? Huh?
No, I did mine to 3 decimals. So mine was 113 times 0.97. 339.291.
You said 113 times 0.97.
Yeah, comma 0.97. I did mine to 3 decimal pieces.
Okay, so this one gave you 339.2 what? 27 radians. Now the D part with the distance covered, Let me just quiz that here because of space. With the D part, the distance covered um, by a point on the circumference of the flywheel after 3 seconds. So the distance covered, which is S is equals to theta r. So with the distance is going to be equals to the angular displacement that we calculated, which is 339.27 multiplied by the radius, which is 0.2. It's going to give us what, Linda? 67,85. So this is 67,85 meters. So this is the solution to that. Let's look at a more challenging question. Okay, an axle. I think I've seen this question before. I don't know which year. I normally use this axle. I think, not sure whether 2018 or 2019. An axle rotates at 200 revolutions per minute. So like I said, the first thing I want to see is your data. So you can write the capital N 200 rev per minute. The first question says that you must calculate the rotational frequency in revolutions per second. So you are going to divide this by what? By 60. So you are going to arrive at what? 200 divided by 60 is going to give you what? 8,33. 3,33. 3,33 revolutions per second. The B part, you have to determine the angular velocity. The angular velocity is what? Is 2 pi n. So this is going to be 2 pi multiplied by 3, what? 3,33. So this will give us what? 20,92 radians per second. The angular displacement after 5 seconds. So angular displacement is equals to angular velocity multiplied by time. So this is going to be 20.92 multiplied by 5. It's going to give us what? 104,62 radians. Please don't forget to put the unit there. The unit is very important. It's half mark for correct answer and half mark for correct unit. Let's look at another question here. This is another typical exam question. 1, 2, 3, 4. It's 13 marks. Okay. The question says that a wheel with a diameter of, like I said, I think I need to create an extra something here. I'm just going to extract the data here. We have a wheel. So a wheel is taken into consideration here. The diameter of the wheel is given to be 0.5 meters. And it takes 5 seconds for this particular wheel to reach a circumferential velocity. It takes 5 seconds to reach a circumferential velocity of 8 meters per second if it accelerates from rest. So the initial velocity will be 0. So the question says that you must determine the average angular velocity. So with the average angular velocity is when you add both the initial velocity and the final velocity together and divide it by 2. You are finding average. And then we can establish from the concept of this question that our initial velocity is 0 because they said it's from what? From rest. So we can write this as 0 plus the final angular velocity divided by 2. So We need to determine the final what? The final angular velocity. We can determine that from this circumferential velocity, which is given to be what? 8, 8 meters per second. Okay. So because that is the final velocity. So we can determine that by using I'll write it as v final is equals to w final multiplied by what? Multiplied by radius. Remember the formula that connects the linear and the angular quantity together, so that we can determine the final velocity is 8. So I can just divide my 8 by my radius. My radius is 0.25. So here I can determine the final velocity, angular velocity of that final circumferential velocity. So this will give us what? To give us what? 32. So this is 32 radians per second. So you have to substitute that 32 inside that. So you're going to have your average velocity is going to be 0 plus 32 over 2. So that's 32 over 2, which is what? 16. So it's 16 what? Radians per second. So the average angular velocity is 16 radians per second. So the second question says that we must determine the angular acceleration. So I'm going to use the next slide here. I'm sure you have the textbook. So with the angular acceleration is the rate of change of velocity. So with the angular acceleration is going to be equals to the angular velocity over time, isn't it? So the angular acceleration, the angular velocity that we are going to use there is going to be the final one. Final, the final angular velocity, we got that to be what? To be 32. Yes, that's going to be 32 divided by the time is what? The time is 5 seconds. So it's going to be 32 divided by 5. We're going to get what? 6.4. So this is going to be 6.4 radians per second squared. So the C part here, you are to determine the linear acceleration, of a point on the circumference of the wheel. So with the linear acceleration, this one is easy. You just use this formula that connects. So with the linear acceleration, we have the 6.4 multiplied by the radius. The radius is 0.25 because the diameter is 0.5 meters. So what would be the linear acceleration? 1 point. So it's going to be 1.6 meters per second squared. So with the D part of the question, you are to determine the angular displacement during 5 seconds. So the angular displacement during 5 seconds, angular displacement is angular velocity multiplied by time. But in this case here, with the angular displacement during 5 seconds. So you're going to consider the average, the angular displacement. You're going to consider the average angular velocity here multiplied by time. We determine the average to be 16. So it's going to be 16 multiplied by the time is 5. 16 multiplied by 5 is going to give you what? 80. 80 radians. The last question there, the distance. How do you determine the distance? We given with the distance is still the same formula. It connects the angular displacement to the radius. So with the distance, it's going to be 80 multiplied by the radius, which is 0.25. So that gives you what? 20. Thank you. That is 20 what? 20 meters. Let's look at question 4. So let's look at that question. Let's look at that question together. That one where they put bicycle there. So I was supposed to give you that as an homework, but we're just going to look at that. So I'm going to be reading from my textbook here because a bicycle, a bicycle wheel, the diameter of the bicycle wheel is given to be 0.6 meters. They said it accelerates from 2, you see now, they just wrote 2 R per S. So that is revolutions per second. So is this from the initial rotational frequency of 2 rev per second set to 25 rev per second. Now it took the wheel 4 seconds to move from 2 rev per second to 25 rev per second. And then the first question says that we must determine the angular acceleration. Angular acceleration is the rate of change of angular velocity. So this is going to be the final minus the initial over t. So this one can be written as 2 pi n final minus initial divided by time. So it's already in rev per second. We don't have to divide by 60. So it's going to be 2 pi. So we'll just subtract them as 25 minus 2. And the time is already in seconds divided by 4. Linda? 30. Are you sure?
Yes. Yes. Oh, no.
Thank you. 36.12 radians per second square. Average angular velocity. With the average angular velocity, of course, then you want to find an average. You need to add the initial and the final and you divide by 2. So you can write this as 2 pi nf plus n initial divided by 2. These 2 can cancel, can have it as pi. We have 25 plus what? 25 plus 2. So this is 27 pi. Linda, give me decimal. 27 pi is what? 84.82 what? Radians per second. The C part of the question, the speed of the bicycle after 4 seconds. So that is the speed after 4 seconds. So this is going to be 2 pi. The radius is going to be 0.3. Yeah, 3. 0.6 the diameter. So the speed after 4 seconds would be 2 pi. The final one there is 25. Then multiply by what? 0.3. So the final velocity will be what? That's the speed after 4 seconds. the speed after 4 seconds. That's the answer, 47.13 meters per second. Just put the time there. Remember, it takes 4 seconds for the wheel to rotate from 2 rev per second to 25. They said from 2 rev per second to 25 rev per second. That time is given already. So they are just repeating the time again. But sometimes they might change the time. Like I said, after 5 seconds or 6 seconds. So you have to calculate. Yes, you have to recalculate again. But in this case, 4 seconds is what we are working with. And then we've already been given the final rotational frequency to be 25 revolutions per second. So we just use it the way it is here.
How do you know if we're using the final or the average?
Because they said after 4 seconds, it accelerated to 25 rev per second after 4 seconds. That's the final. So that's the reason why you are using 25. The D part, the linear acceleration, let me just give you some time to write. With the linear acceleration, you are going to connect, the angular acceleration to the radius. The radius is 0.3 meters. So with the linear acceleration, the linear acceleration is angular multiplied by radius. So you're going to connect the angular acceleration. We got it to be 36. That's the first thing that we got here, 36.12. 36.12 multiplied by the radius. The radius is 0.3. So here you will get your linear acceleration. Angular displacement during 4 seconds. So with angular displacement during 4 seconds, angular displacement is the angular velocity multiplied by time during 4 seconds. So you're going to use the average. Four seconds multiplied by 4. Or you can rather do this, calculate this separately. 2 pi n1 initial with the final 2 pi what nf. So you can substitute those values, initial and final, to use. And then with the f1, let's see the distance covered by the bicycle. Okay, distance, angular displacement multiplied by radius. And then with the g part, the number of revolution made during 4 seconds. Linda, give me the value for the linear acceleration here. 10, guys, what she's telling me is what I'm going to write down here. So you need to confirm. This one, okay, you've not done this one.
339.28.
Is it correct, guys? I'm going to write it there. 339 point what? Radians. Then with this one, it's just going to be 339.28 multiplied by the radius, which is what? 0.3. So I'm going to leave this for you to figure this out. The number of revolution made during 4 seconds. The average rotational frequency, and then you multiply it by 4. For those of you that are done, you can try question 8. Question 8, that's going to be the last question. I think we're almost done with all the activities there. rev per second. For those of you online that doesn't know, so with the average rotational frequency, so this actually means that it's 13.5 revolution in 1 second. So how many revolution in 4 sec is going to be equals to, you multiply 13.5 multiplied by 4. So you're going to get 54 revolutions. So this is how to go about it. Any questions from those online? Question 8. That one that they said a pulley is coupled to an input shaft that's rotating at 4,000 revolutions per minute, and we were given the diameter to be 32 centimeters. That's 0.2. That's 0.32 meters. And the last question we are going to be looking at here is question 8. And then from there we move to torque, work done, and power. The torque, work done, and power. So tomorrow I think we are done with module 2 already. So tomorrow we are going to finish module 2, because the next one here is torque, work done, and power. And it's not really much. Tomorrow is Wednesday. We're going to finish with module 2, and Thursday we're going to start with module 3, which is dynamics. We're going to be looking at the laws, 3 laws of Newton's 3 law of motion. It's a topic that is quite interesting as well. I'll be showing you a lot of things there. Okay, guys, the last one, question 8, just try and do that. Then tomorrow we look at the last aspect of this chapter. Then we know that we are done. Then we move to chapter 3 on Thursday. Any questions?